With the carrier fully exposed in dry dock, the real battle begins, not against an enemy fleet, but against time itself. Decades of ocean service have left their mark. The hull is layered with barnacles, algae, hardened salt deposits, and thick rust scaling that spreads like scars across the steel surface. What once cut cleanly through open water now stands weathered, bearing the evidence of countless voyages, storms, and long deployments at sea. Industrial crews move in with high-pressure water cannons capable of blasting away years of buildup in seconds. The sound is deafening, a mechanical storm tearing history from metal. Sheets of marine growth collapse to the dock floor, washing away in torrents of brown and gray runoff. The steel begins to breathe again. Then comes sandblasting. Millions of abrasive particles strike the surface at high velocity, stripping corrosion down to bare metal. Clouds of dust swirl beneath the massive hull. Every inch of the 1,000-foot structure must be cleaned. There are no shortcuts, no hidden corners left untreated. Because beneath the rust may hide something far more dangerous, structural weakness. Engineers carefully examine weld seams, plate joints, and stress points. Ultrasonic scanners probe the thickness of the steel. If corrosion has penetrated too deeply, entire sections must be cut away and replaced with newly fabricated plates weighing several tons. Welders ignite torches. Sparks cascade like fireworks beneath the enormous frame. Fresh steel is fused into place, restoring strength to the skeleton of the ship. Next comes protective coating. Modern anti-corrosion primers and advanced marine paints are applied in multiple layers, each engineered to resist saltwater for decades. The iconic gray hull slowly reappears, smooth and uniform once again. It's not just cleaning. It's renewal, deliberate, precise, and powerful. The Ghost is beginning to look alive again. If the hull is the body of the carrier, the internal systems are its nervous system. And this nervous system is outdated. Inside the ship, miles, literally miles, of analog wiring snake through ceilings and bulkheads. Installed decades ago, these cables once powered radar systems, navigation consoles, communications arrays, and weapons controls. At the time, they represented cutting-edge engineering. Thick bundles of copper carried signals that coordinated flight decks, guided aircraft through storms, and linked commanders to fleets across oceans. Now, they are obsolete. Teams begin stripping out thousands of feet of aging copper wiring. Panels are opened. Rusted brackets are unbolted. Old circuit boards are carefully removed and catalogued. Dust-covered command consoles are dismantled piece by piece, revealing the maze of infrastructure hidden behind steel walls. Every removed cable is a step away from the past. The goal isn't repair. It's transformation. Modern warships operate on digital networks and fiber optics. Data must travel instantly between radar, aircraft, weapon systems, and command centers. Threats move at supersonic speeds, decisions must move faster. Analog systems simply can't keep up with modern battlefield demands or cybersecurity requirements. Fiber optic cables are installed throughout the ship. Capable of transmitting massive volumes of data at nearly the speed of light. New servers and hardened data centers are constructed deep within protected compartments, shielded from physical and electronic attack. Redundant systems ensure nothing fails under pressure. The bridge receives an entirely new command architecture. Large high-resolution digital displays replace aging monitors. Touchscreen controls integrate navigation, radar, communications, and tactical intelligence into one seamless interface. Even crew living quarters are upgraded. Climate control improves air circulation. Modern bunks replace worn racks. LED lighting reduces. The flight deck is the carrier's crown, 4.5 acres of hardened steel where controlled chaos once ruled. This is where fighter jets thundered into the sky every 60 seconds. Where deck crews, moving with choreographed precision, turned raw steel into air superiority. But now, the surface is worn. Decades of jet blasts have scorched the non-skid coating. Arresting cables are rusted. Catapult tracks show fatigue from thousands of launches. Restoration here is critical. First, the deck is resurfaced with advanced non-skid materials engineered to handle extreme heat and stress. Every marking, landing stripes, safety zones, taxi lines, is repainted with precision. Then comes the biggest transformation. The old steam catapults. For decades, high-pressure steam hurled aircraft off the deck. Powerful, yes, but maintenance-heavy and less efficient for modern jets. Now, engineers install electromagnetic aircraft launch systems, EMALS. Instead of steam, EMALS uses electromagnetic force to accelerate aircraft smoothly and precisely. It reduces stress on airframes, supports heavier next-generation jets, and improves sortie rates. Massive power converters are integrated deep below deck. Energy storage systems are synchronized with the ship's reactors. Every launch must be perfectly timed. Arresting gear is upgraded too, reinforced cables designed to stop aircraft moving at nearly 150 miles per hour in just seconds. This deck is no longer just restored. It's modernized. When the first test aircraft lines up, the transformation will be undeniable. The heart of naval aviation is ready to beat again. Count the words exactly. Below the waterline, deep inside the cavernous engineering compartments, the massive turbines lie in silence, dormant for years. For decades, these engines powered a floating city, converting nuclear energy into unstoppable propulsion, yet now they wait patiently, quiet as tombs. Years of stillness end with a single command: power online. Steam begins flowing from the nuclear reactors into the main turbines. At first, the flow is slow, almost tentative, as the enormous system warms. Pressure builds gradually. Metal expands in response. Every joint, every bearing, every shaft absorbs decades of inactivity, awakening to the force of controlled energy for the first time in years. Technicians monitor vibration sensors with meticulous care. Thermal readings are checked constantly. Even a minor imbalance in a shaft of this magnitude could cause catastrophic failure. Precision is paramount. Then, rotation. The massive shafts, each connected to propellers taller than a two-story building, begin to turn. Slowly at first, then with increasing confidence. The sound is deep and mechanical, alive, resonating through the hull like a heartbeat. Lubrication systems engage perfectly, cooling pumps respond as designed, and backup generators seamlessly activate to ensure stability. Next comes propulsion testing. In the dry dock, rotation is limited, but systems are verified meticulously. Every movement is measured. Every vibration analyzed. Once the carrier is refloated, the true test begins at sea. Engines push forward gently at first. The ship glides through the water under its own power, something it has not done in years. Engineers listen carefully. No excessive vibration. No unstable resonance. No alarms triggered. Speed increases gradually, 10 knots. 20 knots. Nearly 30 knots, faster than most destroyers. The giant moves with authority. The Ghost now has motion. And that motion proves something vital: this carrier can fight again. Its engines, the heart of its might. The dry dock floods once more. Water rises slowly along the hull, lifting the carrier from its massive steel supports. Tugboats stand ready on either side, engines humming, but this time, something is different. The engines of the giant ship are active. The deck is fully restored. The command systems are modernized. Every inch of this floating city has been carefully inspected, repaired, and upgraded. As the dock gates open, sunlight glints off fresh gray paint, reflecting across the water in dazzling patterns. The carrier begins to glide forward, not as a forgotten relic, but as a fully reborn supercarrier, alive and ready to dominate the seas once more. Crowds gather along the harbor to witness the moment. Crews line the rails in dress uniforms, faces solemn yet proud. Flags ripple in the wind, marking the ceremonial rebirth of a ship that was once silent and abandoned. Sea trials commence. Aircraft take off successfully from the upgraded EMAL system, accelerated smoothly by electromagnetic force. Radar arrays scan flawlessly, tracking targets miles away. Communications networks synchronize seamlessly.